Hello students and welcome back to my channel. In this video we'll be discussing numericals based on the intensity pattern of a interference of light. Okay, but maybe what you say, Young's double slit experiment. So here comes the first question, students. You can see two light sources with amplitudes 5 units and 3 units respectively interfere with each other. Calculate the ratio of maximum and minimum intensity. Now we have been given that A1 is equal to 3 units. A1 is equal to 5 units and A2 is equal to 3 units. Okay. Now we have to find the ratio of maximum to minimum intensity. Now we know maximum to minimum intensity ratio will be the square of maximum to minimum amplitude ratio, because intensity is proportional to square of amplitude. Now maximum amplitude will be A1 plus A2, that is sum of amplitudes will be the maximum amplitude, whereas minimum amplitude will be the difference in the amplitudes. So you need to place the values, students. So this is 5 plus 3 upon 5 minus 3 whole square. So this will be 8 upon 2 whole square. So 4 square is 16. So 16 is to 1 is the answer. I hope that is clear. Then moving to the next second question. Two light sources have intensities of light as I0 each. Okay, I0 each. What is the resultant intensity at a point where the two light waves have a phase difference of pi by 3? So in this case, since we have been informed that the individual intensities of each light source is I0 and we have to find the resultant intensity, so we will be using this formula. I is equal to 4 times I0 into cos square of the phase difference divided by 2. This is the formula which we will be using here. So here you can see the phase difference is 60 degree. Half of 60 is 30 degrees. Pi by 3 is 60 degrees, half of this. So this will be 4 I0 into root 3 by 2 whole square. So the end result is 3 I0, because 4 gets cancelled, you can see, students. So this is the answer. Then moving to the next question. Question number 3. The wavelength of light is 450 nanometer. How much phase will differ for path difference corresponding to 3 mm? Now, as we know, students, that a path difference of lambda is equivalent to a phase difference of 2 pi radian. Okay. So based on this, we have a beautiful formula. Since we have to find the phase difference, so I can write delta phi upon delta L is equal to 2 pi by lambda. So we have to find the phase difference. Path difference is how much? 3 mm. So this will be 3 millimeter is equal to 2 pi by lambda. Lambda is how much? 450 nanometer. So we'll get the answer in radian, because this is 2 pi is actually in radian. So therefore we can write like this: delta phi equal to, so 150 is a year. Okay, so we have 2 pi, this 10 power minus 3 goes up, becomes plus 3, minus 9 goes up, becomes plus 9. So 9 and this minus 3, this 3 will go that side. So 9 minus 3 is 10 power 6 upon 150. So finally we have 2 pi by 15 into 10 to the power 5 radian. Okay, students, so this is the final answer. Then moving to the next question, question number 4. The ratio of maximum to minimum intensities in an interference pattern is this. What is the ratio of amplitudes of interfering waves? So we have been given that Imax upon Imin is 36:1. Okay, ratio of maximum to minimum intensity is this. Okay, so what we can do is that immediately we can write this as Amax upon Amin whole square is 36 by 1 and extract the square root here itself. So we have Amax upon Amin is equal to 6:1. Now we know Amax is the sum of the amplitudes, and assuming A1 to be greater than A2, A minimum is the difference between the amplitudes. So either you can cross multiply or you can apply componendo dividendo. So let us apply componendo dividendo. Okay, then you will have 6 plus 1 upon 6 minus 1, that is 7:5 is the answer. Okay, 7:5. Then moving to the next question, question number 5. The ratio of maximum and minimum intensities of an interference pattern is 36:1. What is the ratio? We have already discussed this, so no need to discuss. Same question is repeated, students. Then when interference of light takes place. Now, when interference of light takes place, basically what happens is that instead of having uniform light intensity distribution over the screen, there will be alternate dark and bright fringes. So basically what is happening? The light energy from the dark fringe is being shifted to the bright fringe. So bright fringe will have more than the average intensity, whereas dark fringe will have lesser than the average intensity. So basically, it is a redistribution of energy without any loss in energy, because there is no violation to the rule of conservation of energy. Then, coming to question number 7, the ratio of intensities at 2 points P and Q on the screen in a YDSC where phase difference between the two waves of same amplitude are pi by 3 and pi by 2 respectively are. So just now we have the formula intensity is equal to 4 times of intensity due to any wave, or you can also write this as maximum intensity into cos square of delta by 2. The delta is the phase difference between the interfering waves. So basically, the ratio of intensities will be actually the ratio of cos square of half the angles. So for in the first case, it is 60 degree, so half of 60 is 30. In the second case, phase difference is 90 degree, so half of 90 is 45 degree. So this will be root 3 by 2, and this will be 1 by root 2. So basically it is 3 by 2 is the answer. Okay. So because root 2 gets cancelled, under root 3 by root 2 whole square. So 3 is to 2 is the answer. Then moving to the next question. In an interference experiment, the ratio of amplitude of covalent waves is 1 by 3, the ratio of maximum and minimum intensities. So we have already discussed this. Straight away apply the formula A max to A min. Sorry, I max to I min will be the square of A max to A min. And you know A max is A1 plus A2 and A min is A1 minus A2. So here what you can do, ratio of amplitudes is 1 is to 3. So you can take A1 as 3 and A2 as 1, not a problem. So 3 plus 1 upon 3 minus 1 whole square. So the end result is 16 is to 2. Wait students, here I'm sorry. This will be 4 by 2 whole square. So 4 is to 1 is the answer. Then moving to the next question. Two coherent sources produce waves of different intensities which interfere after interference. The ratio of maximum intensity to the minimum intensity 16. The intensity of waves are in the ratio. Okay. So here what we can do is this. We have been given that the ratio of intensities, ratio of maximum to minimum intensity is 16. So I max upon I min is given as 16, which is also equal to under root I1 plus root I2 upon under root I1 minus under root I2 whole square. Now immediately extract the square root. So when you extract the square root, you will be getting this under root I1 plus I2 upon under root I1 minus root I2, which is equal to 4 is to 1. Now you can apply componendo and dividendo to calculate root I1 upon root I2 as 4 plus 1 upon 4 minus 1. So finally you square it to get I1 by I2 as 25 is to 9. So 25 is to 9 is the answer. Moving to the next question. Two coherent sources. I'm sorry students, just a minute. Two coherent sources, monochromatic intensities I and 4I are superposed. The maximum and minimum possible intensities in the resulting. So maximum intensity will be under root I1 plus under root I2 whole square. This formula you have to memorize. So when you put this as I1 as I and this as 4I, so this will be root I and this will be 2 root I. So overall it is 3 root I. When you square it, it will be 9I. Similarly, I min is equal to under root I1 minus root I2 whole square. So when you put this as root I1 as I and this as 2 root I, so basically it remains I itself. So 9I and I are the correct answers. Then moving to the next question. Two coherent sources of intensity alpha interfere with the fringe visibility. Find the fringe visibility in the interference pattern. Now fringe visibility is defined as the difference in maximum and minimum intensities to the sum of maximum and minimum intensities. Okay. So now we have been given that the ratio of intensities is alpha. So we have been given that I1 by I2 is alpha, ratio of intensities, right? So this will be, here Imax is actually under root I1 plus under root I2 whole square, whereas I min is under root I1 minus under root I2 whole square, whole divided by root I1 plus root I2 whole square plus root I1 minus root I2 whole square. Okay. So here applying the formula a plus b whole square minus a minus b whole square, we'll be having 2ab, sorry 4ab, I'm sorry, 4ab, and a plus b whole square plus a minus b whole square is twice a square plus b square. So this will be twice under root I1 I2 upon I1 plus I2. Now dividing the numerator and denominator by I2, we can write like this, dividing numerator and denominator by I2. So finally you have twice of root alpha upon 1 plus alpha. This is the final answer, students. Then let us move to the next question. Probably this is the last question. So two covalent monochromatic light beams of intensities 994 are superposed with a path difference of, sorry, this should be a phase difference, with a phase difference of this one, the intensity of the resulting beam. So intensity of the resulting beam is this. Straight away we will apply the formula, students. So this is the formula. So I1 is how much? We can, I1 is 9i. I2 is how much? It is 4i. Plus twice root 9 is 3, root 4 is 2i, and cos 120 degrees is minus half. So just you can cancel this, 1, 2 and 2 gets cancelled here, and we are left with 9 plus 4 is 13i minus 6i. So the end result is 7i. 7i is the final answer. So that's all, students, in this video. Thank you so much for watching my channel. Kindly subscribe to my channel and hit the like button.